Hello, Assalamu alaikum. We're entering a brand new block on a brand new day. We're entering day 7. Two of our tasks for today is to cover the topic percentages. That's what we would be covering as far as the quantitative is concerned. And I would like to remind you that we're also going to be doing one table every day. So we've done the tables all the way from 1 to 6. We're going to be doing the table of 7 today, 7 times 1 all the way through to 7 times 20. That's it for the quantitative part. For the verbal part, we're going to be doing the basics of analogies, basically an introduction with a few questions as far as the verbal part is concerned. Again, I would like to remind you that we're going to keep up with our habit of adding 5 new words into our vocab journal every single day. So those are the 2 things that I'm expecting you to do on your own, and these other 2 things we'll be doing together. We'll be starting off with percentages. Let's go now. Percentage, when comes to mind, obviously the sign comes to mind, so this is the sign of percentage. When we say percent, we're referring to it as per. Cent, if you know, it's a Latin word that comes from century, it means 100. So it's per 100, or over 100, or out of 100. That's what percent stands for. So from now on, the minute that I think 8%, I know they're talking about 8%, which is 100. So 9%, 29 per cent. And I know cent stands for 100. That's that thing per 29%. 98% would then be 98%, right? I see fractions coming in. That means percentage, and fractions have something or the other to do with each other. Let's check out what. Now, basically, fractions and decimals that we've done fractions and decimals already. Percentages, what we're doing in this particular topic, are convertible. You can convert one into the other. So we're looking, how do we convert percentages into fractions or decimals? Now, I have a 20% written over here. I know that's 20%. That's 20%. Same thing as saying 20%. Is that a fraction I see over there? Yes, I do. I can always simplify it. 0 goes off with the 0. 2 times 1 is 2. 2 times 5 is 10. That's 1 over 5. So that 20% is the same thing as saying 1 over 5. That's as far as the fractions are concerned. If I wanted to convert it into a decimal, I would say, do we see it? This is like 20. Per is the same thing as saying division. So 20 divided by 100. We know it's 20 divided by 100. I understand the decimal to be after the 0. And because I'm dividing, the decimal moves backwards. How many spaces? 1, 2. We've got 2 zeros. 1, 2. So the decimal ends up coming over here, and I've got a 0. Which means 20% is the same thing as 1 over 5. Also the same thing as 0.20 or 0.2. Same thing. It's not a difference. 0 after the decimal makes no sense at all. Likewise, okay, here, give it a try. I want you to convert this into a fraction and a decimal. So a fraction, it would be 31 over 100, correct? Can I simplify it anymore? Not really, it doesn't look like it. How about changing it into a decimal? I know it's 31 divided by 100, so it moves back 2 decimal places. I've got a 31, the decimal's supposed to be here. 1, 2, that's where it comes up being, so that's how much it is in decimals. So 31% is the same thing as saying 31 over 100 as a fraction, or 0.31 as a decimal. How about when I'm converting things from percentage to, from fraction decimal to percentage? Now, if you realized over here when I did this, percentage to decimal, what I did was I divided by 100, right? We were dividing by 100. So when I move in the opposite direction, when I'm going from fraction decimal to a percentage, what I would do is multiply by 100. So let's take a look at the first number over here, 0.16. I'm expected to change it into percentage. All I need to do is multiply by 100 times 100. That would give me, the decimal moves forward because it's multiplication, 2 decimal places. So what I end up getting is a 60. The decimal's in the end here. If I write it down or I don't write it down, exactly the same thing. So I end up getting a 60%. When I multiply by 100, I need to replace it with that sign of percentage. That's that. Next question, 0.23, exactly the same thing. It's the same thing as saying 23% because I multiply by 100 and the decimal moved forward. I've got a fraction over here. The next question, 24 over the next example, 24 over 100. What do I need to do again? Times it by 100. So times 100. Oh wow, the 100 and the 100 cancel out each other. One's in the numerator, the other in the denominator, and I end up getting 25%. How about this one over here? Again, I do the exact same thing, times it by 100, the 0 goes off with the 0, 4 times 10 is 40%. So now that we know that fractions, decimals, and percentages are all interchangeable, you can go from one form to another, I just realized that there's nothing new in this topic at all, because I know fractions and decimals from the previous block. Nothing new with percentages anymore, right? Okay, let's move on. What we're going into is attempt these 4 examples, just to make sure that we understand what we're getting into, and if we know how to interchange decimals, fractions, and percentages. So they want this in decimal. I know percent sign over here means divided by 100, so the decimal moves back 2 places. That gives me 0.2045 as a decimal. Done. 30% is, I know it's 30 over 100. Off in mathematics represents a multiplication sign, so I have a times. 0.4, what should I do? I'm thinking I'll write it as a fraction because I've got a fraction on the left-hand side, so I'll write this as a fraction as well. 4 over 10. Decimal becomes a 1 and there's a 0 here, and then all I need to do is simplify. 0 goes off with a 0, 3 times 4 is 12, over 10 times 10 is 100. I can simplify this if I need to, or if it's required, I can divide, not by 6, by 2. Divide by 2, that gives me a 6 over 50. Hey, I can divide by a 2 again, that gives me a 3 over 25. So that's the simplified version of this question over here. Next question, how much is 60% of 0.8? 60% of 0.8, so I'd say, okay, 60% of, again, I'd rewrite it as 8 over 10, everything's in fractions, it's very easy to work with, I've got a 48 over 100. I can simplify it down, divide both by a 2, let's say. A 50, I'll divide by 2 again, that's over 25, and looks like that's the simplified version. Can you tell I find the fractions easiest to work with? So I converted everything here into a fraction, because I personally find fractions very easy to work with. If, for example, your comfort zone is to work in decimals, go on, not a problem. Your final answer over here could be in a decimal, percentages, anything, not a problem. Next question, again, like I said, I find fractions so easy to work with, I need to change everything into a fraction. 25 and 100. I'll divide that by, actually 25 goes in 100 4 times, but if you don't know what I would do, divide by 5. Divide by a 5. So I get 5 times 5 is 25, 5 times 20 is 100, 5 times 1 is 5, 5 times 4 is a 10. So I'm left with a 1 times 4 over 1 times 4. That's 1 over 16. Final answer. Now that we know they're interchangeable, all of these fractions, decimals, and percentages, let's go to a kind of question that you would be facing finding the percentage. So when a percentage question comes up, one of the ways of going by it is, as we did in the previous examples, change percentages to fractions to decimal and work them out. Else, what we would have sometimes is questions looking like this. What percent of 15 is 30? What percent of 16 is 4? When these kind of questions come up, the easiest way to go through them is to just follow what they're saying. Let's take a look at the first one here. They're saying what percent, yeah, I know that's percent, of, I know in math is multiplication, 15 is just here, 30. Let's read it again. What percent of 15 is 30? So that means it's equal to 30 is equals to in this particular case. And because what is something, I'll just say it's an x, I don't know what that is. I just formed an equation. Do you see? I just formed an equation. So what this states is x from here, percent is over 100, I'll rewrite it as over 100, of, that's multiplying here, 15 is a 30. Do you see what happened? We just followed exactly as what the words stated, and we ended up forming an equation. So x over 100 times 15 is 30. All I need to do now is find the value of x. So what I would do is divide this by 15, divide this by 15, so I get rid of 15 from the left-hand side, I end up taking it onto the right-hand side. I would also multiply by 100, so I cancel out the hundreds on the left-hand side. The only thing I'm left with is an x on the left-hand side, and on the right-hand side I have 30 over 15 times 100. So what I did was moved everything in the equation, this is my equation, moved everything in the equation from the left-hand side to the right-hand side. This is going to come up a bit more in the next topic where we're dealing with algebra, but I hope you can manage this small amount of equations for now. So all I need to do is now simplify this. 15 times 1 is 15, 15 times 2 is a 30, 2 times 100 is a 200%. Answer. So what percent of 15 is 30? Well, it's 200%. Next question. What percent of 16 is 4? Exactly the same thing. Give it a try. What? I don't know what that is. I'll just write it as x. What percent? I know percent is 100. Of in math is multiplication. Of 16 is 4. What percent of 16 is 4? That's it. I got an equation. All I need to do now is shift everything from the left-hand side to the right-hand side. What I do is becomes 4. 16 basically, what happens when you're moving anything from the left-hand side to the right-hand side is that the operation reverts. Multiplication becomes division, so it would be over 16. And because 100 is in the denominator over here, it's being divided. On the other hand side, it would be multiplied. The operation changes on when you're moving any number from one side of the equation to the other side of the equation when you're moving anything over an equals to sign. So that's 1 and that's 4. 100 divided by 4 is a 25. 4 times 1 is 4. 4 times 25 is 100. So I end up getting a 25%. Next question, 25,000 is what percent of 20,000? 25,000 is what? I don't know what that is. What percent of 20,000? Exactly the same thing. I'll move everything from the right-hand side to the left-hand side in this case. So 20,000 is being multiplied. When it goes to the other side, it divides. 25,000 over this 20,000. I'm planning to take it onto the other hand side. 20,000 is x percent. Percent, I'll just write it as over 100. 0, 0, 0, 0, 0, 0. Everything cancels out. Shall I take 100 to the other side as well? Because I not need it here. So I multiply both sides by 100. That 0 goes off with this here. And 2 times 1 is 2. 2 times 5 is a 10. 5 times 25 is 125%. That's that. Next question, 13 out of 20 cans are recycled. What percent is that? Now, if you're ever trying to find that percentage, something out of something, for example, you scored a 13, God forbid, you scored a 13 out of a 20 in your math test. So I would say it's a 13 out of a 20. See how you can convert it into a fraction? So 13 out of a 20, that would be 13 out of a 20. When you're changing, so I did get a fraction over here, but I want it in percentage. How do I change a fraction into a percentage? I just multiply by 100. That's it. I found the equation. They want the answer. They're saying what percent is that? So 0 goes off with the 0. 2 times 1, 2. 2 times 5, 10. 13 times 5. How much? We've done a table of 5, right? 65. So it's 65%. Next question, 150 is 25% of what number? 150 is 25% of what number? Exactly as the question states, I'll say 150 is equal to 25%, 25% of what number? Let's just say x, I don't know what that number is. I'll take that 25 over 100 to the other hand side. What I do is, remember the operation reverses, so basically what I'm doing is multiplying this side by 100 over 25. So I have to multiply the other side by 100 over 25 as well. Why did I do that? So that I can cancel the 100 with the 100, 25 with the 25. The only thing I'm left with is the x over here. So x equals to, now let's work on this. That's a 4. 100 over 25 is a 4. 25 times 1, 25. 25 times 4 is 100. You can go by the table of 5 over here as well. You can go by the table of 5. 5 times 5, 5 times 20, and then simplify, you'd end up getting a 4. 4 times 15, Phil, 4 times 15 is a 60. And the 0 carries on. So that's 600%. Oh, very big value. 4 times 15. Next question. 100 is what percent of, 100 is what percent of 80? 100 is what? I don't know what that is. What? So I'll say 100% is over 100 of 80. What I could do is, basically, this cancels out with this. So what I have is I'll multiply this side by 10 over 8. Have to multiply the other side by the exact same thing. Why did I do that? I can cancel the 8 with the 8 and the 10 with the 8. 10 with the 10. The only thing I'm left with is an x. X is equal to, it's 1,000 over 8. It's 1,000 over 8. I know that one. We did that a few days ago. That 125 times 8 is 1,000, something that we must know. It comes up a lot. It comes up a lot. So this is a product that we do need to know. So 8 times 1 is 8. 8 times 125 is 125. 125%. Last question, 78. 78 is 15% of what number? So I'll multiply both sides by 100 over 15, multiplied by 100 over 15. So this cancels out with this, and this cancels out with this. All I'm left with is an x. Equals to, then I have 100 times 75 over 15. I know that 15 and 75 come in the table of 5. 5 times 3 and 5 times 15. 3 times 1 and 3 times 5. That leaves me with a 500. Oh, 500 seems too big. Oh, well, it's because I think this is a mistake over here. Let's just fix it. This number is 75. 75, except please, this number is 75, it's not a 78. 75, it's not a 78. So that's 500%. What number only? So I don't need to put percentage over here. 500 only. Answer. Okay, let's go on to the next thing. It's like I'm racing against time. There's so much to do and so little time. Next thing that we need to know is the percentage increase and the percentage decrease formulas. Whenever anyone asks you about a percentage increase, what you do is it's the increase out of the original times 100. And if they ask you about the percentage decrease, if something's decreasing, what you do is you work out the decrease divided by the original times by 100. Let's try these examples to know exactly what we're talking about. Katie earned £40 per week for her part-time job. Her pay increases and now she gets £42 per week. So she went from £40 to £42. How much was the increase? The increase is £2. £2. So if I need to find out the percentage increase, I'm going to be using the formula. It's increase, which is £2, over the original. The original that she was getting was a £40, times 100. So that's how I'll work it out. What I would do is cross out the 0 to 0. So I'm simplifying 2 times 1, 2 times 2, 2 times 1, 2 times 5. So that's a 5%. So she manages to get a 5% increase on her pay. Next question, we're looking at decrease. It's an example for percentage decrease. Sarah goes to buy a shirt that costs 96 Saudi riyals. She uses a discount card and gets the shirt for 72 Saudi riyals. So how much was the discount then? She got 24 riyals off. Yeah, she got 24 Saudi riyals off. What percent discount did she get? Well, to find out the percentage decrease, what we need to do is find out the decrease. So it decreased 24 Saudi riyals. That's 24 out of the original. How much was the original? She had to pay a 96. So 24. She gets 24 off the 96 times 100. So all I'm doing is just applying the formula. That's the table of 12. If we don't know it already, you could maybe start using the table of 2. But I'll go by the table of 12. 12 times 2 and 12 times 8. 12 times 2 and 12 times 8. Can I simplify a bit more? Yes, 2 times 1 and 2 times 4. Now I'm left with 100 in the numerator and a 4 in the denominator. Be a bit careful when you're simplifying, because when you're simplifying, like, you can lose track of which was in the numerator, which was in the denominator because of so many slashes out there. It gets a bit messy. So it's 100 in the numerator and a 4 in the denominator. 100 divided by 4 is a 25%. 100 goes in for 25 times. So it's a 25%, you get a 25% discount. So these are the two formulas that you would want to keep in your mind. You can even use the common sense when it comes to percentage questions, because we deal with these kind of situations, what Katie's facing and what Sarah's facing, almost every day. So we can use common sense, or you can remember the formulas, up to you. Next, let's start, finally, let's start the practice on percentages. I think we've got about 15 questions. I encourage you to pause the video. This is in the worksheet. You've got the practice on percentages. Start filling it in. So pause the video, mute it, and try and be ahead of me. Work out the solution, and then come and double check your answers. Let's go. Question number 1. Ahmed's dad gives him a pocket money of 50 Saudi riyals, so he's got a 50. And asks to give 20%, so he's expecting him to give 20% of the amount he has, which is a 50, to his sister. How much does the sister get? So 20% of the 50 is given to the sister. 20% is 20 over 100. After this multiplication, 50 here, I formed an equation that you solve and get the answer. 0 goes with the 0, 1's in the numerator, the other's in the denominator. 0 goes with the 0, again, there's 1 in the numerator and 1 in the denominator. So all I'm left with is 2 times 5, which is a 10. So the sister ends up getting 10 Saudi riyals. Next question. And he spent 10% of the money he had. If he had a total of 1,600, so he has a 1,600 Saudi riyals, and he spends 10% of it. So 10%, well, does it make sense if I say 10% of 1,600? Exactly the same thing, I just converted it into an equation. What's cancelling out? Those 2 0 go off with these 2 0, and 160 is gone off. Now, mind you, because most probably you would just end up writing this as the answer, but take a look at the question itself. If he had a total of 1,600, how much does he have now? So he spent 160. He had a 1,600. And he spent 160, which leaves him with how much? Because they want how much does he have now? 1,440 Saudi riyals. That's the amount he has now. When a question similar to this, or maybe on a more difficult level, comes up in the GAT, they are quite smart to give you this as an option, and they give you this as an option. So the minute you get this answer, you're tempted to just write it down, circle it, and move on. Be careful. When it's a double-step question, you want to be a bit alert with it. Next question. Yasmin bought 3 perfumes and paid 2,100. So the total that she's paid is 2,100. The second was 50% of the first. Oh, so the first is, let's say, I don't know how much it is, let's just say X. So the second is 50%, which means a half of X. And the third is 25%, which means a quarter of X. So he's got 1, 2, 3 perfumes. The second is a half of the first one. This is the first one. The second's half of the first one. And the third's a quarter of the first one. 25%. What were the prices of the 3 perfumes? If I need to work that out, what I would do is add them all up. So I've got the first perfume, the second perfume, and the third perfume. I need to work out this. It also looks like an algebra question to me now, but no problem, it's a bit basic, I'm sure that we can manage it. What I need to do is make the denominators the same, because remember, you can't add fractions when the denominators are not the same. What I would do is, in order to make them the same, I'll multiply this by 2, multiply this by 2. Multiply here by 4, and multiply here by 4. So I have 4x over 4, plus 2 times 1, 2, x over 2 times 2, 4, plus 1 over 4. Now, do I have the exact same denominators everywhere? Yes, I do. I can add them all up now. So I've got a 4 in the denominator, 4x plus 2x is 6x, 6x plus 1 is 7x, I have a 7x, 2,100 equals 7x over 4. Okay, but I want to find out the value of x, right? Which means I need to take the 4 and the 7 onto the other side, so I multiply by the reciprocal both sides. Why did I do that? So I cancel the 7 with the 7 and the 4 with the 4. I'm left with an x only is equal to what? 7 times 1 is 7, 7 times 3 is 21, and the zeros carry on. 4 times 3 is a 12, and the zeros carry on. So I know that the first perfume was 1,200 Saudi riyals. Let's write 1,200 Saudi riyals. The second perfume, I don't know how clear that is. 1,200 Saudi riyals was the price of the first perfume, 1,200. The second one was half of it. Half of 1,200 is a 600. And the third one was a quarter, so it's another half then. That's 300 Saudi riyals. Those were the 3 perfumes. Let's move on. Next question. 15% of x is 60. 15% of x is 50. It's a straightforward question. Why? Because they've given it to you already. 15% of x is 60. Here you go. All I need to do is take the 100 and the 15 onto the other side. So if I multiply on this side, I've got to multiply here as well. 15 goes off with the 15, 100 with the 100. All I'm left with is this portion. Now that goes in the table of 5. It also goes in the table of 15, but let's move with 5. 5 times 3 is 15. 5 times 12 is 30. 3 times 1 is 3. 3 times 4 is 12. 4 times 100 is 400. So that means they were saying 15% of 400 is 60. That's your answer. Next question, 60% of 2 minutes. Actually, I forgot to say that the answer is supposed to be in seconds. So what I would do is, I'll change 2 minutes into seconds. That's 2 times 60 seconds, right? 120 seconds. And although I'm interested in 60% of it, so I'd say, okay, 60% of 2 minutes. Of 2 minutes, which is the same thing as saying 120 seconds. 120 seconds. What do I have now? 0 goes off with the 0. 0 goes off with the 0. 6 times 12, 72. So 72 seconds. That's 5 questions done. 10 more to go. Question number 6. The car Leila wants to buy is 6,000. The car Leila wants to buy was 6,000 and now it's increased by 15%. How much money does she need to buy the car? Hey, is this a percentage increase question? Looks like it. I'm going to use the formula. Percentage increase is increase over original times 100. So what's the increase? It's increased 15%. I'll say 15. Actually, no. I'm going to do it an easier way. Sorry about that. I'm going to do it a much easier way, which is, okay, now it's increased 15%. So the car's price was 6,000. So I'll say 6,000 was the original price, but another 15% increase. So would it be right to say if I say 15% of 6,000 was the increase? So I'm working out 15% of 6,000, which is zeros go with the zeros. 6 times 15 is a 90. 6 times 15 is a 90, and the 0 carries on. Don't worry if you don't know the table of 15 yet. You will very soon when we go into the table of 15. But hey, it comes in the table of 6 as well. 6 times 15, we know that's 19. So that's 900. Now, by the way, 900 is the increase. What do they want? How much money does she need to buy the car? So the car wasn't 6,000, and now she needs another 15% of that, which is a 6,900 Saudi riyals, is it? That's it, that's your answer. By the way, you can do it in multiple ways. Like I was about to use the percentage formula back there. You can use this procedure over here. Some people will just use their common sense and conclude to the answer straight away. Really up to you, whichever works out the best, but as long as that's the final answer. Next question. Alfred buys an old bike for 4,700 Saudi riyals and spends 800 on its repair. So because he bought an old one, he pays this much, and he has to get repaired a few things as well. If he sells the bike for 6,600 Saudi riyals, his gain percent is what? This is also a percentage gain question. So I'm thinking I'll use the formula this time. Percentage increase is increase over original times 100. How much is the increase? By the way, the original money that he paid was because he did buy the car for 4,700, but then he also paid the 800, right? So originally he paid a 5,500 Saudi riyals on it. That was the original price that he paid. So the original is 5,500. How much is the increase from a 500 to a 6,600? The increase is 1,100 riyals. So I'll write it down here. Increase is what he sold it for. He sold it in profit. Take away this. That's the increase. So here and here. Increase over the original times 100. That 0 goes off with the 0. 0 goes off with the 0. 11 times 1 is 11. 11 times 5, 55. 5 times 1, 5. 5 times 20 is 100. So I'm left with the 20%. That means he got a profit of 20% when he sold his bike. Next question. A man buys a computer for 1,400 Saudi riyals and sells it at loss. So this is a percentage decrease question. 15%. At what price did he sell the computer? So there was a loss of 15% on the computer. That means I could say that there was a loss of 15% on the original amount, which was 1,400. So I'll say 15% of 1,400. Zeros go off with the zeros. Zeros go off with the zeros. There was a 15%. Oh, did he? Okay. 15 times 14 is 210. Again, if we don't know the table of 14 and 15 yet, we will very soon, so we don't need to worry about that. 15 times 14 is 210. Now, by the way, was the percentage was the loss, right? 210 is the loss that he had, and now at what price is he selling the computer? Well, he originally bought it for 1,400, and now it's had a loss of 210. That leaves him with this is the answer. Because I didn't manage to work it out because I thought 0 take away 0 is a 0 will be something there, so I thought, okay, that's the answer. You can work it out if you like. Next question, they're saying a fruit seller had some apples. He sells 14% of the apples and still has 420 apples. Originally, he had how much? Well, if he sold 40%, that means he's left with 60%. All right? Would I be right to say that 60% of the total number of apples that he had are left over, which is a 420? So he sold 40% and he's left with 60%. Then I'm saying, and I know that he's left with 42. 60%, 420 apples. So I made up a statement saying 60% of the total should be a 420 then. I'll just make this into an equation and work it out. Of the total, I don't know, 420. I'll multiply it both sides by the reciprocal of the fraction so that they cancel out. All I'm left with is this part here. The 0 goes with the 0. 6 times 1 is 6. 6 times 7 is 42. That leaves me with a 700. So he originally had 700 apples. Next question. What percent of number from 1 to 70 have a 1 or 9 in the units place? So I can see that this is a unit, like 1, 2, 3, 4, 5, 6, 7, 8, 9 are the unit digits, and I have 11, which has a tenth place and a ones place, 12 units and 10, so basically I'm just trying to identify what the unit digits are. So they want a 1 or a 9 at the units digit. Let's say I'm going to start counting from 1 to 70. So 1, that's in the units place. 2, 3, 4, 5, 6, 7, 8, 9, that's in the units place. 10, 11, there's a 1 in the units place. 19, there's a 9 in the units place. I'll just follow that through. 21, 29, 31, 39, 41, 49, 9, 51, 59, 61, 69. So those are the total number of numbers that I have, where from 1 to 70, where 109 is in the units place. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's a 14 numbers out of the total, because they're saying what percent is that. Remember, percentage is whatever you're considering over the total. Whatever you're considering over the total times 100. So we're considering these numbers over here, which are 14 in value, out of the total, which is 70, times 100. Now that goes in the table of 7, 7 times 2, 7 times 10, 2 times 1, 2 times 5, times 1 times 20, I'm left with the 20%. So that is my answer, 20%. Next question. Okay. If A is x% of 4, and B is y% of x, then which of the following is true? So they're comparing x and A and B. Now A is x% of 4. B is y% of x. I think I made a mistake. This shouldn't have been, this thing here has to be a y. It's not a 4. It has to be a y. X% of y, y% of x, that's how it goes. Okay, so I'll just rewrite this. Of y. Yeah? A is x% of y, B is y% of x. Do you see that they're exactly the same things? Because this is the same thing as saying xy over 100. It's the same thing as saying yx over 100. Exactly the same thing, so they're both equal. Next, we've got, I think, 4 more questions. Yep. Okay, question number 12. If 20% of A is B, 20% of A is B, then B percent of 20 is what? Is the same as what? So do you see that the answers are in terms of A? I'm going to try and work this out in terms of A. 0 goes with the 0, 1, and that's 5. I'll multiply by 5 here, I'll multiply by 5 here, so I cancel them out. I'm left with A equals B times 5. Now, what they're saying is, oh, actually, I could have done it the other way around. Okay, yeah, it would have been easier had I just left it the way it was. Here. So that's 1 and that's 5, right? So 5 times A is a B. Oh, 1 over 5. It's not in the, it's in the denominator. 1 over 5, A equals B. Done? Now that's the final thing that I got, but they're not interested in B, they're saying B%, which means over 100. So I'll say over 100, because I divided by 100 on the right-hand side, I have to divide by 100 on the left-hand side as well. Now, that's in the denominator, that's in the denominator. You might be wondering why is she multiplying, but actually when something is in the denominator, it's the equivalent to saying you're dividing it with something. So, which is why I have 100 in the denominator, and then they're saying off 20. So off 20, off 20. Now, isn't this what they wanted? Which is exactly the same as this thing over here. And so you're expected to work on the left-hand side. On the left-hand side, here. So 5 times 1, 5 times 4. So that's 4A over 100. Is that the same thing as saying 4%? 4 over 100 is 4%, right? 4% of A, which is the first option over here, and that's that. I hope it's clear. Let's move on to the next question. Sarah spends 45,000 Saudi riyals and is left with 10% of the money. How much did she have initially? Well, if she's spent 10%, if she's left with 10%, how much did she spend? So she's left with 10%. So she spent how much? We know that the total in percentage is 100%, right? If 10 is what's left, what's spent is 90, so that they add up to give you 100. So she's left with 10%, she spent 90%. Would I be right to say that 90% of the total amount of money that she had is what she spent already? She spent 90%, which is the same thing as 45,000. So 90% of the total is 45,000. That's the expression I have. I'll just need to change it into an equation. 90% of x is 45,000. I need the value of x. I'll multiply both sides by the reciprocal of the fraction. Reciprocal, not the exact fraction. Reciprocal of the fraction, 100 over 90 times 100 over 90. 100 goes with 100, 90 goes with the 90. All I'm left with is this over here. 0 goes with the 0. 9 times 1 is 9, and 9 times 5 is 45. So that's a 5 with how many zeros? 1, 2, 3, 4. 1, 2, 3, 4. That's a 50,000. 50,000, so initially she had 50,000, she spent 45 and is left with 10%. So that's the answer, 50,000. Next question. 20% of x is 1 over 7 of 84. Easy peasy because they've given me the entire thing already, so it's 20% of x is I'll just write it as an equals to. 20% of x is 1 over 7. I need to get the value of x. I'll multiply by the reciprocal of the fraction. By the reciprocal of the fraction, so this cancels out with this, and this cancels out with this. I'm left with this quotient only. 0 goes with the 0. 2 times 1, 2 times 5. I'm getting something very weird. 20% of x is 1/7. Oh. I'm so sorry. Let's redo this. Well, I hope you have the video on mute, and you're doing it on your own, so you wouldn't get stuck here with me. Again, 20% of x is 1/7 of 84. I missed this number. 84. Now, I know 7 times 1 is 7, and 7 times 12 is 84. I also know that 0 and 0 cancel out, so 2 times 1 and 2 times 5. That leaves me with x over 5, so I have 1 times x in the numerator and 5 in the denominator is equal to, I've got a 12 only on the right-hand side. I'll multiply both sides by 5 to be able to get rid of this, so I have x only is equal to 12 times 5 is a 60. Oh, it was that easy. We messed it up initially. Actually, I messed it up initially. So 60 is your final answer. Last question on percentages. 1,200 students passed the exam out of the 1,600 student. What percent is that? Remember we said whatever we are considering over the original or the total what you want to call it, times 100. That's what we're using over here. So we're considering 1,200 students out of the total, which is 1,600 students, times 100. Zeros go off with the zeros. 3 times, no, actually 4 times 3 and 4 times 4. 4 times 1 and 4 times 25. 3 times 25 is, I don't know, but I do know that 3 times 20 is 60. 3 times 20 is 60, 3 times 21, 22, you can carry on and you get 75%. So 75% of the students passed. That's it. We're done with the table with the percentages. I'm reminding you to do the table of 7 today. It's very, very, very important. And then we'll continue while you're doing that. Put the video to pause, and then we continue with the analogies. Right, we're starting with analogies, which is one of the 3 components that make up the verbal section for the GAT test. Now, why is it so important? Analogies is probably the only part in the verbal section that sort of tries to twist your mind, which is why we try and study it a little bit. What does it constitute of? Why are we studying it all together, etc., etc. So basically, why are we doing analogies all together? Why are the GAT people expecting you to know analogies? Well, because it tests your ability to reason with words. So you're reasoning with words. You see, it's not just English. They're checking a lot of logic and common sense in you. And then they're also checking if you can recognize the relationship between ideas. Oh, ideas is a huge thing. So they're checking out if this is the analogy over here. They're checking out the many underlying concepts and skills that they're checking within you. So solving analogies promotes critical thinking. That's nice. So they're checking your critical thinking skills. They're checking your vocabulary and your ability to identify association. So this is a multi-concept, multi-skills checking questions, let's say. So they're checking multiple skills in you using analogies. Let's go forward and try and look at what analogies are. An analogy is a way of expressing the relationship between words. So you're taking words and you're trying to relate between them and trying to find out what's the relationship between them. For example, what we've got over here is this. The way that we read out an analogy is, we'll say student is to a class as player is to a team. That's how we read analogies. Student is to a class as player is to a team. So do you see the connection between player and a team, student and a class? That's how they're saying that analogy is a way of expressing relationship between words. And one thing that you could use, it's a very helpful technique that you could use when you're solving analogies, is to use something called a test sentence or a bridge sentence. A test sentence or a bridge sentence, which is this thing over here. So when they read out the analogy, this one up here in the example, they thought, okay, how about if we put this into a test sentence? We say a student is a member of a class, and then a player is a member of a team. So do you see how they've built a bridge sentence to be able to relate between the words? So I encourage you to use test bridge sentences to be able to work around your analogies. Now, there are 3 strategies that you can look into when you're solving analogies. There are 3 strategies. First of all, never ever rush through them. Never ever rush through them, because you've got an analogy, you've got 4 options, and you're rushing through it, you're like, oh, this sounds very close, let's tick it, move on to the next question. No. You want to read through it really slowly, concentrating on the words. Really slowly means like take about 10 to 15 seconds. Don't go through them really quickly. And the second thing that you're doing is when you're reading the words, you're looking for the relationship between them. You're looking for the relationship between the pair of words. So you're going to be asking yourself questions like, hey, how are these things similar? Are they different? How are they similar? What is the connection between them? So you're asking yourself questions to be able to find out the relationship between the pair of words. Let's take a look at an example. Let's say, like we said, we were going to be using it in a logical test sentence, bridge sentence. For example, attorney and client. What's the relationship between them? We did the word attorney in our vocab last block. That means a lawyer, right? So basically, an attorney helps a client fight a case, right? So basically, an attorney helps a client. So they're saying a possible test sentence could be an attorney helps a client in legal matters, right? So I can say a money helps a bank. No. A forest helps a squirrel. No. A doctor helps a patient. A plumber helps a sink. A plumber helps a sink. No. So basically, this is like career related. This is career related. Attorney, doctor. Attorney is helping a client. A doctor is helping a patient. So do you see how we build something called a test sentence and apply it to the question, and then apply it to the options as well to be able to work out which is the closest. So these are the 3 strategies you can use when you're attempting the analogies. Let's take a look at 10 questions in total only for today, and then we focus a bit more onto this tomorrow and the day after and the day after. Let's start. Question number 1, they're saying whale is to ocean as a camel is to blank. And you've got 1, 2, 3, 4 options to choose from. Now, the bridge sentence, the test sentence that they came up with over here is a whale lives in the ocean. Isn't that true? So the relationship between the whale and the ocean is that the whale lives in the ocean. So the camel should live in, a whale lives in the ocean, the camel lives in the desert. Camel lives in the water, no. In a caravan, no. In a desert, yes. In a herd, well, it moves around in a herd, doesn't live in a herd. So that's it. The answer is desert. Let's apply the same thing to question number 2. Question number 2, they're saying accept and reject. Now, I'm trying to think what is the relationship between these 2 things. I'm trying to see what's the relationship between these things over here. Accept and reject. How are they related? Well, they're the exact opposites of each other. When you don't accept something, you reject it. When you don't accept something, you reject it. Here, I formed a test sentence. When you don't accept something, you reject it. When you don't understand something, you deny it. I'm working on this slide now. Well, maybe. When you don't assume something, you deny it. When you don't accept something, you reject it. I'll write down the bridge sentence. So I'm saying, this is the bridge sentence that I've written down over here. So I'm saying, when you don't accept something, you reject it. When you don't assume something, you deny it. Not really. When you don't refuse something, you deny it. Not really. When you don't acknowledge something, when you don't acknowledge something, you deny it. This looks quite true. So I've got this one over here that's to do with understanding, and this one over here that seems more accurate compared to the first option, which is why you've got to be reading through it really slowly and focusing and concentrating on the words. When you don't acknowledge something, you deny it. I take that as the answer. Next, question number 3. Tree and forest. So a tree is a part of a forest, right? A tree is a part of a forest. A tree is a part of a forest. So that's the bridge sentence over here. If a tree is a part of a forest, well, all of these options are to do with words, because now I'm checking word has to be a part of something, right? Because if a tree is a part of a forest, the word has to be a part of something. It's a part of this, and this. But then we're looking into a lot of trees make up a forest, right? So a lot of words are going to make up a dictionary, because although they have words in them, but all these three things have words in them, but it's not what it's made of. This is to do with facts and figures. This is to do with facts and figures. The definition is only of a particular word definition. But dictionary is to do with words. A lot of words combine together to make a dictionary. A lot of trees combine together to make a forest. So it makes perfect sense. If I look at the next question over here, question number 4. Eclipse and moon. Hey, what's that got to do with each other? I know that when there's an eclipse, it covers the moon, right? So I'll say eclipse covers the moon. That's the only relationship I can find between them. Eclipse covers the moon. So what's covering the stage? The sun covers the stage, the curtain covers the stage, illumination, light. So the curtain covers the stage just like an eclipse covers the moon. This one was kind of easy, nothing complicated there. Question number 5. Now, when something is an exaggeration, it forms a tall tale. When something is an exaggeration, it forms a tall tale. When something is unbelievable, it forms a fantasy. Fantasy is something that's unbelievable. It could be time travel. Time travel could be a kind of fantasy. Magic could be a kind of fantasy. You could have fantasy in a novel. But overall, something that's unbelievable is fantasy. Now, this question was a bit tricky because they had this and this as semi-answers as well. Again, that's why we're reading it very slowly, trying to go into the question and each and every word and try and come up with the best possible solution. Question number 6. Now, this is a tool. Oops, what did I do? Now, this is a tool that the surgeon uses. It's like a long thing, sort of pointy in the front. It's used to perform surgery. So basically, a surgeon performs surgeries and uses this tool here. A painter paints and uses what tool? Well, he paints on the portrait. He paints a portrait on a canvas with a brush, with paint. So do you see how brush is very similar to this? Although the painter is using all the 4 things, but because it's this tool, this long tool with a sharpened something that the surgeon uses, I'm going to go with brush because the painter uses a brush to draw and the surgeon uses this tool to perform surgeries. Question number 7. Historian. That's something that the astronomer does to space. Well, the astronomer studies the space. The astronomer studies space, stars, everything outside. So it's space and stars and sun, etc. And what does the historian study then? Historian studies the past. Historian studies the past, just like the astronomer studies the space. That's it. Well, the astronomer studies space and stars and a few other things, because not everything out there is space. It has other elements to it as well. But then a historian can study the past. Historian also writes. Historian also does research, etc. So I'll go with past as the answer. Question number 8. Latitude, longitude. That's very easy to do because latitude, longitude are these lines on the Earth, on the surface of the Earth. So these are the latitudes and the longitudes. These are the latitudes. Do you see that they are sort of horizontal? And these are the longitudes. Do you see that they're sort of, vertical? So that's the answer. This one was a bit straightforward. Okay, next question, question number 9. Something that has safety has security. So they are similar. They have a similar meaning. Something that has safety has security. Something that has protection has dangerous. God, adventure. Something that is adventurous is dangerous. Not necessarily. Perilous, it has the exact same meaning as dangerous because it means full of danger and risk. So it's full of danger and risk. So I'll go with this word here. Question number 10, surplus is something that's in abundance. Again, they have very similar meanings. Something that is surplus is in abundance. Something that is deficit is like you have a shortage, or it's the opposite of abundance. So something that is surplus is abundant. Something that is deficit is not enough, is not an amount, and it's not efficiency. It's shortage. The definition of deficit is that anything in deficit is sort of in shortage. That's it. We're done for today. One thing I would like to remind you is the vocab. Vocab, you're going to be adding 5 new words into your vocab journal. You can feel free to choose anything from here that you did not understand, so that could go into your vocab journal as well. And we're done for today, and I'll see you tomorrow. Take care till then and keep shining.